Okay, so it's time to get started with the keynote the afternoon session. The first topic of the afternoon session is a keynote speech, and it's keynote speech by Steve Bourne, and his name is famous for original author of the Bourne shell in Japan, I think. But he is also one of the people who evolved Unix development in early days. The speech is entitled as Early Days of Unix and Lessons Learned. So please welcome Mr. Bourne.
Thank you. Okay, let's see if we can make this thing work. Welcome everybody. Thanks for inviting me. Excuse me, I'm going to try not to do that. So let me just run through the outline of the talk so you get an idea what I'm going to talk about. I'm going to talk a little bit about I was 10 years at the math lab in Cambridge before I went to Bell Labs. And we're going to talk a little bit about the language design decisions, the conflicts in the language design and why it got complicated and how we fixed all that. Well, we fixed as much as we could. And then there's some stories about why we did the way we did things. And at the end, talk about some lessons we learned. So the math lab in Cambridge, when I was there, I'm really 100 years old. So one of my supervisors, that's the person who teaches you in Cambridge, was a famous numerical analyst, they called him in those days, analyst. And so he claimed, JCP Miller, claimed that he could beat a computer software solving a differential equation the first time on this machine. So you gave him a differential equation, he would solve it using this machine, and of course if you wrote software it took you forever and you had bugs in it, but this thing didn't have any bugs in it. And so that was the JCP Miller story, and he was a great guy. The other thing that we did when I was there was we had an early compiler for what became my Algol 68 compiler. It was called Z70, and Mike Guy and I were fooling around, and John Conway, who used to come to visit Mike Guy, because Mike Guy was a good mathematician, he was my co-conspirator in the Algol 68 work. So John Conway would come in on a Friday night. We used to work at night because it was a timeshare computer, and the best response time would be at like 10, 11, 12, 2 a.m. And so we would be there at 9, we'd be drinking tea, and John Conway would come in and chat away with Mike about some things I didn't really understand, even though I did mathematics as a graduate. And so anyway, and then one day John's fooling around with this life game idea, this machine he designed. And so Mike and I said, well, why don't we just write your program to it so you can display the results on the PDB-7, which we did. So we ported our compiler to the bits of the compiler we needed to make the program that we wrote work, and that was the first life game and that's how he found, using this visualization, how he found the actual rules of the life game, which it turned out to be. So Algol 68C was the compiler I wrote, and it was the development work beyond the work from the Z70 I talk about. It was intended as for use for algebra systems, so what today you would call MATLAB. So it was an early version of that, and I actually did my PhD thesis on this topic. It had an instruction set that we would generate. So Z code was a flat assembly language that we would generate, and it was parameterized so that you could tell how many registers there were on the machine you were generating code for, and then because it was flat, you could relatively easily translate it into your assembly language. I'll talk more about that later. And Z code, it turned out, was the instruction set. David Wheeler, I went into his office one day and I said to David, well, what are you going to use for an instruction set for the cat machine? He said, I don't know. So I said, why don't you use Z code? Because that made my life a lot easier for making the compiler work on the cat machine. So that's what we did. The compiler itself has recently been ported to the IA386. I'll talk about it a little bit later. I don't want to spend too much time on it now. The reason I'm talking about it now is because a lot of the design decisions in the shell you can see derived from my what's the word, biases with respect to languages that came from Article 68. It did have a minor influence on C, and I'll talk about that later as well. So that's how I got to Bell Labs. I was at Cambridge with Wilson, Wheeler, and Needham, and people like that. The algebra system, I talked about that. So I had a summer job in 1973, and IBM T.J. Watson with Fran Allen she was doing PL1 compilers. I forgot what I was doing. I wasn't doing a lot of useful things at that time. Anyway, I did end up getting a job offer at Bell Labs at the time, and I went there. So let me just get to the point here. So a number of you know about this already, but I'll just summarize it because it informs the later conversation. So Dennis Ritchie's article, which I'm sure many of you have read, which is at the bottom of this slide, is the one to read. That's the one that has most of the good stuff in it. But this work was funded by some text processing stuff that Joe Osana and Doug McElroy were working on in the early days. Of course, the original operating system was put together by Ken with Dennis because they actually wanted to play Spaceball, I think, or something useful like that. And it had, as you know, hierarchical file system, blah, blah, blah. So, and the C language developed through BCPL and B, and it's interesting because BCPL was something in Cambridge, and that came from something that Chris Strachey did called CPL, which, if you're interested in languages, that's a piece of language history. The shell that was in the original Unix that I'm talking about here, which was the first 5 years of the 70s, was a simple shell. It simply was recording of what you would type at the terminal. So it would record it, and it would then execute what you recorded. So you couldn't use scripts as filters because if you think about it, the standard input would be the thing that you're reading. And it didn't have much in the way of control flow, so it was very simple. So who are the key players? So Dennis, who's no longer with us, he wrote C in the drivers. Ken did the kernel on the shell, Doug McElroy did pipes, and Doug McElroy was sort of a snowball guy. That's what his passion was about. And so he was into string processing and stuff like that. Robert Morris, whose son we know from the exploits in the 80s, and was it Robert Morris Jr.? Anyway, Robert Morris, his father, was there at the time, and a good friend of the house. He did the login stuff and the security stuff, so he ended up at the NSA as a staff person there. Joe Osana did MLTUF, you know Brian, you know Mike List, I'm sure, so you know these people. So what did we have at the time? What we had at the time was a couple of adjoining rooms in an attic, probably the size of this room, maybe, in total, PDP 1145. And from the sublime to the ridiculous, we had 133 teletypes, and we had Tektronix 4014s. And the Tektronix 4014s was a really nice big display that was used for seeing the text processing output, but it was great for software development as well. And of course, during that time, we progressed from 300 baud modems to 9600 baud modems, which was really exciting when it happened. So what are the rules of the game? Software releases, when you installed some software in that environment, it was kind of personal if it didn't work. Like you heard about it right away. That's how software should be developed. In other words, in my opinion, you need to know if it doesn't work, you need to take it personally. I'm not sure everybody in the software development does that, but that's how we did it then, and I think that's the way to do it. The source code and the man pages are online, so that made life very easy. I think the man page culture has sort of gone away. Man pages are now 400 pages long, and in the old days, the man pages would tell you what the good bits were, and there weren't a lot of good bits, so that was fine. So, and the other thing, as you know, which some of the talks here, I've heard a little bit of this as well, your output, if you wrote something, was going to be somebody else's input, so you were always making sure that if there was output, that it was useful and it could be read by programs. At least that was the idea. So one of the things in this upstairs room I'm talking about, there was a speaker on the wall. It was a voice synthesizer, and it would come along a bit like the ones you hear today from, and it would come on about 2 minutes to 1, and it would say, "The cook is going downstairs," and so that would be lunchtime. So everybody go off down to lunch. And of course, at night, I already pointed out. So that's the Tektronix 4014. That's the best picture I could find. Got something on it. And you know, you could put 2 pages side by side. Pretty cool. So the other thing, this is a little later than but in the mid-70s. So these are the discs, the RPO6s from digital. And the story here is that one day somebody spilled some coffee on the surface there. And Ken was kind of grumpy about this because he had to, you know, they trashed the disk. And, you know, the disk with all the system on it and everything, so we had to go to the backups and everything else. So the next day, this notice appeared on the disk. Sorry, it's a joke. So, but it did get people's attention. So in these days, it was the 6th edition Unix system. It was written in C. There were 40 system calls, which is probably about as many as anybody can really need. Sorry, guys. The grep man page was 20 lines long. Pretty cool. And this system was actually used outside of the research group itself. It actually was published within Bell Labs. And you know, it was simple stuff. And so you can see all that. So here's the man pages. Here's the listing. And you know, you've seen all this, but the nice thing about this is I'm done with with section 1 already. I'm in section 2 already. And then I'm done with section 2. What's wrong with that? Of course, there was functionality that wasn't in the system at the time, so I'm not trying to be too cute about it, but I do think we do have a lot of system bloat these days. So, and then in that time from when I got to Bell Labs in 75 to 78, we were actually working on the 7th edition system. I wrote the shell and ADB and a bunch of other stuff that nobody cares about. And I was actually porting the compiler because I was still interested in doing that. And of course, the compiler was bigger than the address space for PDP-11, so we actually did put overlays in as an exec option. And I had to go fiddle with the loader to make the loader work. The linker, I'm sorry, not the loader, the linker. And then in 77, Eric, who's sitting here, who was at Berkeley, had a program called Trek, and that was actually the most important of the utilities I'm talking about here. And so we had a lot of fun with that, and Eric and I went back and forth making improvements to that, and my kids even remember us playing that. And can you imagine playing Trek on the Model 33 telesite? Clap, 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 clap. And of course that's good because it gives you time to think about your next move. So, and then in 78 we actually did the 32-bit port. The 7th edition was published, a bunch of file system improvements. And this was really the last release that the Unix group actually ever did. And then after that it got dragged off and things happened to it after that. There was a talk this morning by Daniel, who's here somewhere. And so I'm going to just mention this. I wasn't going to mention this, and then when he gave his talk this morning, I think, oh, I'll throw the slide back in. So when I wrote ADB, it was the machine I compiled it on, and the machine I was debugging, and the machine it executed on were all the same machine. So that makes life really easy, well, relatively. But then we started doing the 32-bit port, and I had to make the debugger work so that you could compile it on one machine, run it on a second machine, and debug a third machine. And actually, that sort of fried my brain, and I gave up. And but I did see in Daniel's talk this morning some clues about how people have solved this problem. And so, if you want an intellectual problem to play with, that's a good one. So, 32-bit port was done on the Interdata. We used to call it the Interlemon. And then the VAX showed up, and so we moved it to the VAX. Of course, we found on the PDB-11, the address 0 had 0 in it. So if you indirected a pointer through address 0, you just got 0. And so there were a whole bunch of bugs in the code because people did that. And it took a while to find them. I'm going to talk a bit more about sbreak later, but one of the things I did in the shell was use sbreak and to increase my memory. And I said to Dennis one day, well, if I get a fault, memory fault, up against the limit, can I just allocate more memory in the fault routine and go back to what I was doing? He said, sure. So I said, yay. So I'll tell you why that's important later. But that caused people doing ports to other machines so much grief that we probably shouldn't have done it. We probably should have found some other way to do that. I used to go to Unix conferences in the 80s, and people would come up to me and grab me by it. I said, it wasn't me, it was Dennis. And so the other thing that happened in this time frame was, of course, Bill Joy and the guys at Berkeley were doing their thing, and the 32-bit port we had in the labs did not have virtual memory support. And what Bill and the guys at Berkeley had done was put in the virtual memory support. So one day, I invited Bill to come and talk at the labs, and of course he was late. He claims the plane in Chicago didn't land or didn't take off or something. Anyway, Bill's late, but when he does show up, he's got one of these old 1200 reels under his arm, tape, and BSD 3.0 on it. And so I said to Bill, what's that? He said, yes, BSD, bumble. What does it do? Well, it's got virtual memory. I said, oh, really? I said, does it work? He said, of course it works. So I was running a lab at the time with 3 or 4 Baxes, and they were doing Lisp work. And so they were hitting the memory limits on the physical memory and were dying for a decent virtual memory operating system. So Friday night, Bill and I went into the computer room. We jacked all the disks up because the disk format was different on a BSD from the one that we were running. Jacked all the disks up, installed the operating system. It worked. I came in on Monday morning and said to my boss, guess what I did over the weekend? He said, what? I said, well, I changed the operating system, all the computers were running. So, does it work? I said, yeah, it works. That was it. And everybody was very happy with that. And Bill, Bill, to his credit, by the way, this was the first time that we had brought BSD back to Bell Labs. And I'm not sure you may remember, but I'm pretty sure it was the first time it had come back to the lab. And so Bill acknowledged later the risk that I was taking. And so that was fine, it worked. Did it work? Yeah, it worked. So let's talk about release management. So these days, it's much more complicated than it used to be. But in those days, if you wanted to change the source for something like the loader or the linker or whatever I did, if you touched it, that means if you opened the file, you owned that program. You weren't allowed to touch it unless you were prepared to take ownership for it. And so, and that's kind of a good rule. And and then also in the 7th edition, we had man page executables and stuff. And I did a bunch of the work on putting the structure in place for that. But one of the things we did, at that time, Make had just been introduced, and people were a bit sloppy about whether they had Make files or not. So we enforced the rule that said if you put it in the source directory for publishing, for release, you have to have a Make file. And so what we would do is we'd occasionally run a script, and if it didn't have a Make file in the source directory, we just delete it. And that got people's attention. But we didn't have source control in those days, and we did just run compiles from the release tree. So that's what the 7th edition was about. So let's talk a little bit about the shell itself as a language, and I'm going to go through some of the design issues, some of the changes we made early on. And I was looking at my notes. I've got a bunch of old emails and stuff, and it's quite a substantial amount of corner cases and detail that I'm not going to go into today, but I'm always constantly surprised when I go back to see all the little corner cases there are that, if you're interested, we can talk about later. So then I'm going to talk about the early changes, the implementation, selling it, its acceptance, and then some of the lessons, things I wish I'd done differently. So why did we start? So at the time, as I said, the original shell was written by Ken. It was simple, didn't do much. It wasn't programmable, couldn't use shell scripts as filters, blah, blah, blah. And so a bunch of people had started to fix that, fix in quotes. And so Dennis and I were in a meeting, I remember it was December, and it was in Murray Hill. I can tell you what room it was. And we came out of the meeting with yet another proposal to patch over the original shell design, which couldn't be patched for various reasons, which I'm not going to go into in detail. The other thing, and when we came out of the meeting, we sort of looked at each other and went, we're going to have to go fix it. So that was my job. I went to go fix it. And that was how we got started on it. Of course, the other thing was that Ken, who owned the original shell, had gone to Berkeley for the year. And so while the cat's away, guess what? I got to work. So, and Ken was okay with that. He wasn't making any changes to the original shell. And John Massey also had a shell in the Programmers Workbench group, which was a big production group at Bell Labs at the time. And they had started work also on some quite reasonable improvements to the shell. So, we started writing code in 75, the first version got deployed in 76, and didn't take long to write the code originally. But then a bunch of iterations happened after that, and I'll go through some of them, which didn't really settle down until 78 when we shipped the 7th edition. So, as a language, it's actually one of the few languages, I think BCPL is the only one I know, maybe other language experts can correct me, which is sort of typeless. In other words, there's only one kind of object, and one kind of thing in there, and that's a string. And so, and they are first-class citizens, and they're the only citizens in their language. And of course, because you want the shell to be both interactive and scriptable, the interactive dominates the way you do things. So you can't use normal programming language rules, which is where you would quote strings, and where unquoted strings would be like reserved words. And so the blank was really the delimiter, because that's what you normally type when you're typing. You just expect to type with blanks. You don't expect to have to put quotes around things that you would in a programming language. And of course what its job is to provide the interface to Unix. And actually there was something somebody said to me earlier. He said, why can't you close the file in each shell? Think of it. So it has variable substitutions, control flows. Signal management is actually quite difficult. I'll come back to that in a minute. And of course it does process management. And it does have evaluation in there so that you can get things evaluated, for example, commands and stuff, whilst you're in the shell itself. So what does it have? Environment variables, I'm going to talk about that a little bit. That was a long discussion. And the reason environment variables was a long discussion, I put it in the shell before we got it into Unix. And it was in there for a couple of years. And so what it meant was in shell scripts, you could pass name values to other shell scripts, but you couldn't pass it through processes. And that's because we didn't have support in Unix for environment variables. And the reason I did that is because I didn't want to have to write shell scripts where I had some context, and then I would have every script have to know which things were in the context and hand it down as you went down through scripts. So that was the reason we had it, and that was the reason the inheritance was the way it was. But it did take a while to get it into Unix, and I'll talk more about that in a minute. And then, you know, the other stuff. The thing that we missed at the time, we thought that commands were the functional abstraction for the language, and of course they're not. You know, you really do need functions as well as commands as a way to have some abstraction. And so we didn't put functions in, I didn't put functions in early on. And in fact, just before I left the lab, we did design what the functions looked like, and they went into some later shell. So, what does a language look like? What does it look like as a language? So some of the things I stole from Algo 68, and one of them that drove quite a lot of the decisions was that in Algo 68, everything is a closed form. So, you know, the conditionals and the loops and all those things are a closed form. So you can take any primitive thing in the language and replace it with one of those closed forms, and assuming some value gets delivered that's appropriate for the context, you can, it'll work. And so this was a way of transformational property of the language I wanted to have. And the other thing that is true is that you can basically have anywhere in the language you could do anything you like. So if you want to put a command substitution in the middle of something, you could do that. And so it has, as a language, it has complete recursion like that. The string quoting rules are still not perfect, but they are better than they were when I started, so I'll talk about that as well in a minute. One of the amusing things, I think it was amusing at the time anyway, so to do conditionals, and we use the exit value from commands to do conditionals. And so in those days, nobody had exit values. You know, they just wrote the command, didn't bother to put the return mumble at the end of the program. And so you got random numbers out. So we wanted to have programs have exit values so that we could use it reliably to do, you know, if command, mumble, mumble. So how do we do that? Well, what I did is, after the prompt, actually before the prompt, when a command got executed, I print exit equals, some number. And that lasted about 3 days, and I got beat up, but everybody went and fixed their commands because it was kind of in public. What do you mean exit equals 402 or 27 or some other number? So it wasn't very popular for a few days, but it did get the job done, otherwise it would never have got done. So language battles. So at the time, and maybe still now, a lot of people wish that it was not looking like Algol 68. So sorry, that's what we did. And so there was a lot of battles at the time to try to make the shell look like and be like C. And so here's my note, which I wrote in 1977. I don't know if you can read it. I'll just read it out to you for those of you who can't see it. It says, since there seems to be no hope of C becoming an expression language, which is what I was aiming for, in which case it would be potentially more suitable for the shell, there is equally no hope that the shell and C will be the same language. The worst problem is the if-then-else problem, which C requires a look at. The point is, in the C context, if you're interactive, the C syntax just doesn't work unless you have two forms, one for if-then and one for if-then-else. And so that was why I kept the closed forms, because you knew you weren't done with it until you got to the end of it. So what McElroy did, he called this the word drow problem, if then else phi and KC stack and all that other stuff. And so he said, well, why don't we do this way and use curly braces? And we could have done that. It may have, it would have been fine. It was not quite so clean, but we could have done that. Didn't do that in the end. And that was the next slide. This one's about the if then else and how do you deal with dangling else's. And so we gave up on that and just kept it the way it was. This was quite amusing though. Somebody said, well, why don't you just throw away all these ifs and stuff and just use ands and ors? And so I thought it was pretty good. I sent this to an email and somebody said, why don't you do that? I said, well, okay, we can do that, but can you read the thing at the bottom of this screen? Because the line above it is actually much easier to read in my opinion. And so, but that's what you'd have to do if you use ands and ors. So, which is kind of ridiculous, so we just kept it the way it was. And there was a fight about the case syntax. And in the end, I don't know if I wore them out or if they just acquiesced or they thought it was a good idea or whatever. But we did ended up with the way it is today. So, and there are reasons, if you look at these constructions, why the form that is being proposed here, which is use curly brackets, doesn't work so well. And that's this slide's an example of that. So the environment variables, moving on a bit, this was the thing that took a couple of years and a lot of discussion to get Dennis to agree to. And this is the comment here. As I said, the shell had this keyword mechanism, which actually I stole from TSO on an IBM MVS system. They had keywords in there, and I thought they were a good idea. And so we had to introduce something into the Unix to make it uniform between shell scripts and C programs. And so there was kind of debates because using the x equals y notation was a bit of a problem. The first iteration of this was I just chose x equals y, and wherever it appeared, I used it to set variables. That's a problem because dd and some other commands have that as argument form. And so in the end, we agreed to put x equals y before the command name, and that would set variables. Then anything like x equals y after the command name would leave it alone. And so that was the compromise on the syntax side of it. To get the environment variables to work, though, you want to make sure that there's no child surprises. That was the golden rule in Unix, that child process wasn't surprised by something the parent did. And so what we did is we had the keyword parameters settable, and as you know, the environment variables ended up being put into the exec system call. And so the way we did the rules was, first of all, processes can have their own local names, which makes sense. And by default, names are local. In other words, you have to do something to have children. This is the no child surprise rule. You have to do something to make the child get the name, which is what export ended up being. And names, it's also, the other rule is that children are not supposed to be able to protect their parents. in the real world, if that were true, that would be kind of cool. But so that means that there's no transmission of information back to the parent from the environment. So the environment has to be per process. Otherwise, if you had it more global on that, then the child could change it and the parent would see it, which is not what you want, because that was one of. And of course, the last comment here is that the process shouldn't have to be a postman for all the names that are in the environment. Meaning, if you're sitting there in a process and there's a context with name and value pairs, you shouldn't have to know what they are to pass them on to the next guy. Otherwise, it's crazy. I mean, you can't write code like that. So this is how long it took to get this into the system. And in the end, it just says, as you can see, we modify the shell to take advantage of exec_VE, which is what the exec call ended up being. And we also put the export in there. And look. So that took a while. A lot of conversation about that. And John Massey and Dennis Ritchie and I were basically the people who were working that out. So quoting hell, it's still quoting hell, but anyway, let me talk about how we tried to make it less obnoxious than it might have been. There are 4 mechanisms. Argument splitting, which is when you're just reading stuff and it's blanks and you split the arguments and parsing commands. And that's when things like special characters like and or and pipe symbol break things up. Parameter substitution, class substitution, and file name generation. They're the evaluations that the shell does. And there's still, in fact, if you ask me, I have to run it sometimes to figure out what things do. But those things get done in a certain order. And you don't go back and redo it. Always, it doesn't go round and round, you just do it once and you're done. As opposed to some languages where the evaluations like that go on and on and on until there's no more change. Which means that things like when you set variables to the value of another variable, it doesn't re-evaluate the blanks and do something else with it. And there are 2 quoting mechanisms. The first quoting mechanism I put in was a double quote. And then McElroy said one day, well, I really don't want to have to know what's going on, and so can't we have another one? So that he actually got the suggestion in to put the single quote mechanism in. And I noticed the other day I was looking at some man page for some shell somewhere, and they have yet another one which allows backslash to be interpreted. I think the VSD shell does that. $quote. And so if you look, you can see an example of the way things get evaluated. And it was meant to be not intuitive, but it was meant to be so that it was as surprise-free as you could imagine, but I'm not sure we really succeeded in that. And so here's what we did in response to number changes, blah, blah. And this was early on also in '76. We were experimenting. Originally, dollar was used as the quoting character, and everybody was already familiar with using backslash, so we switched to that. And so you can see the kinds of changes we were making early on. And we added the single quote mechanism at that time as well. Sorry. So the other thing we put in, I stole this from somebody as well, was here documents. And a couple of things we did with here documents as we went along the path here. Originally, they were interpreted, meaning they were evaluated, so that if there was command substitution, it would take place in the here document. And then what we did over time was put in a mechanism so that you could have a literal here document and one that was evaluated. And we also changed some of the notations here. There's quite a lot of change in the notation in the first couple of years, which turns out we got away with. You'd think that with people doing development it wouldn't happen. And so the other thing we'd done early on was we'd had names for some of this, things like the current process number was $process or something. And eventually we realized that we could be using things that were otherwise unused, which was to steal the second character after a $sign because that wasn't used. And then the other thing we did is we added the $@, which allowed you to essentially replicate the arguments exactly as they had showed up to you without being interpreted. So again, you can see the kinds of things that went on there. So this was 77, and this is actually when we sold somebody else. I'll explain when we sold in a minute. But at the end it says modifications, right, it runs twice as fast, uses less space, and I put some bugs in there, but I don't know what they are. So, and then just to give you an example of the amount of detail, this is actually a short list. The actual real list is a lot longer than this, as you'd expect. And these are all the kinds of things, the corner cases that we were working on. And so we put in dynamic storage management variables, bunch of changes to parameter substitution, the case pattern matching. You can see this list, and as I say, this is just a list of from 77 of all the things we changed. And for example, could you pipe in and out of a loop? You know, you have a loop and then pipe in or out to it. Didn't work originally, and we changed it. We upgraded the pattern matching. You can see that, so that you could have pattern matching in the middle of the file name directory name. And then things like wait. Wait was not interruptible in the old days, and so we changed things like that to be interruptible. So a lot of changes. So we did finally settle down. I'm going to talk a little bit about the implementation, because that was the people who had to do the Unix for weren't happy with us for a couple of reasons, like I told you about the S-break thing. But one of the things that was really important, a lot of the commands at that time, maybe still, had limits on string length for various things. So, you know, you'd type something and it would say, oh, that's too big for this program, please go away. So I said, I'm not going to have any limits on any of the strings or anything else. The only thing that is going to be a limit is the amount of memory. And, you know, so it's completely dynamic from that point of view. But then I had to figure out how to make it actually run fast doing that, because that's non-trivial. And I didn't have my own heap. I couldn't afford to use malloc, and I'll explain why in a minute. So I did my own memory allocator, and then and debugging that was actually a pain for 2 or 3 months to debug it, and I'll explain, you can see why in a second. The error recovery, reporting, and dealing with signals is also quite tricky in the shell, and took a fair amount of time to get that right. I mean, there's an example you can see. You've got a here document that you're going to copy to the standard output, and it's going to be in the background, and you don't want to have it interrupted when you hit Control-C at the terminal. And so the signal management actually did take a while to get ruled right. The rules are actually fairly simple, but it did take a while for me to figure out how to do that. Number of trips down the corridor to Dennis's office. So what did Unix look like at the time when we were doing all this? So I want to talk about the implementation now, and I want to explain the context here, because somebody actually asked me yesterday, when he said, did you use Yak? The answer is no. And the reason was because it's way too heavyweight for what you want. The amount of parsing the shell does is kind of trivial. You know, it's maybe 2 or 3 pages of C code and you're done. So you don't really need something as heavyweight as Yak and Lex to do that. Although I did get lobbied, a bunch of people would say, why aren't you using Yak? That's the best thing on the planet. And I said, yeah, it's not that complicated. So I did it on my own. And also at the time, there was no standard I/O, and there was no string copying routine, so you had to do all that yourself. And this was being invented as I was doing this. Dennis was making that stuff happen. One of the other things that happens in the shell is you can get an error anywhere, and so you have to be able to have a way to get back to somewhere safe and recover. And so I persuaded Dennis to put set jump and long jump in so that you could, you know, put a handle somewhere in the code and say, well, if things get really screwed up, we'll come back here and we'll start again, which is what we do. So, and this is not particularly meant to be defensive, but a number of people said, why don't you use a C-line? Well, C-line wasn't really there, it didn't do much. And so, you know, you don't, and you'll see in a second when I talk about the memory allocation why I couldn't use malloc. So, let's talk a little bit about the C language at the time. And C when I got there, had, I don't know if you remember PL1. PL1 had structures which were offsets. It was a base and an offset. And you could take any offset and apply it to any base, and you could get to the field. You know, you get to the structure element. And between 75 and 77, Dennis changed that to be more like the Argo 68 structures, where the structure is the field. You can only take the field from a structure that has that field in it. And so that changed. I can never get over this point as we're explicitly referencing, but that's because of my Argo 68 bias. And L values and R values, I still get confused about that, but that's okay, I'll get over it. And we did add unions though at the time. And then the other thing is that functions in C are sort of flat. You know, there's just one flat namespace of functions, right? And so you can't really have what I call true recursion in C, because you can't have functions within functions and so on. And at the time, all the functions returned a value. So I get kind of irritated, you know, writing this function and it doesn't have anything to say, so I'd just like to say nothing and say I'm done. So I did eventually talk Dennis into putting void into C. And the way it happened was, I went in his office one day and the light bulb had gone off. He said, you know, if I put void in as a function return type, I wouldn't have to load the return value in the return sequence. So it saved a whole instruction in the return sequence, and that's what got void into C. And because at the time, performance actually mattered. I mean, maybe it matters today, but one instruction in the return sequence was a big deal. So that's how we got void in. Nothing abstract, nothing religious, just practical performance. So, standard IR talked about that, interface as well. Okay, so memory management. So, the way the shell works is it reads in a script, it gets to a point where it's read an element of some kind, puts it in memory and in some tree or something or other, and then it goes and evaluates that. And then when it's done, it throws that away and gets on to the next thing, down the script. And, you know, if the script is a single element, the whole thing, it'll read the whole thing and do it. So basically, it executes and evaluates from an internal tree. And it does that recursively. So, and during the evaluation, anything goes. And so this example here, you can see, you know, I'm setting a variable to the result of executing a command which has a here document in it and does some reading and stuff. So that's kind of complicated. And so you can see, and you know, you could put more of that kind of stuff in there and make it more complicated. And so you can be, so you put this stuff that you're reading on the stack because the stuff that you're reading for the command is going to go away at some point. And then, but during the process of executing that, you may actually have to allocate an arbitrary amount of heap space to store variable values. So you've got some stack, and you can't use the C stack for this because there's no way we're allocating space on the C stack to do things like this. And so we ended up interleaving the heap and the stack, and I don't know if you can see this, but this is actually upside down. At least on the PDP-11 it's upside down because the stack came down from the top, the C stack, which is the code that's being executed, and that was not useful for my purposes. So I took the bottom of memory here and ran an S-break up to the middle of the picture here. You can see where it is. So, and the S-break point is where the top arrow comes down, and that's where the heap and the stack, my stack, are interleaved. And so if I get to the point where, and so the other point of this is at the top of the stack here is where the current string is being expanded. So if you look at this point here, as you're constructing the current string, it's being constructed on the top of the stack here. And so you can run out of memory doing that, and I couldn't afford to put my own bound checking on the string copy, because that would be, think about it, I mean, you know, star thing plus plus equals character is one instruction on a PDP-11. If I put my own bound checking in, that would be like 3 or 4 instructions per character. Couldn't afford to do that. So I just would run the string up until the S-break failed, and then get the fault, get the memory fault, allocate more memory, and go back and continue what I was doing. So that was the reason why we won the performance wars with this code, and why everybody hated it. It's because nobody knew, it was never documented properly, that S-break behaved like this in the fault routine. And if it was, nobody read it. I don't believe it was documented. So anyway, this is just another more detailed picture of the same thing, where, you know, the base of the heap, and then what would happen is I would get stack items of my, you know, commands and stuff that were in the command tree being executed, covered up by heap items, and so I would keep a chain of stuff that would go back into the heap once the item got thrown away. And there was a person, and last time I gave this talk, and I found out who it was, but Akira Nakamura, I don't know if I said that correctly, annotated the source of all this mayhem I was causing in memory management and everything else, took the whole thing, and I still have it, and it was very cool. He'd written the whole thing out and explained the whole of this memory allocation scheme and various other things that went on. And There's also, in terms of looking at the memory management, Jeff Collier wrote an article, which is online easily accessible, which does also talk about some of the ways that the implementation was done. So how do we get the Unix group converted? So the Unix group was the first, that's the group that I was in. So I told you about printing X equals after each command, and then we did do some of the things. People complained a long time about the goto going away. The original shell had goto in it, and that was the only control flow there was. And in the end, we just, you don't really need it, and we don't have it, and nobody's complained since. So that was probably okay. And then it took about I don't know, about a year to get the group converted, and then the rules of this game were, if you convinced Dennis that you could put it in /bin and call it sh, then you were done. And one day, I think Dennis agreed to it, because he was the gatekeeper for the release tree. So we got it in there, and that was good. And as I say, that took about a year. So, other groups in the lab, the Programmers Workbench group, which was a development group in the lab, already had significant investment in the Mashi shell, which was this alternative I mentioned before. And so we had to talk these guys into doing the conversion. And I'm not going to go into this in a huge amount of detail. I will, if you like afterwards, but I can tell you or not. But you'll see at the bottom here is the rules of the game. They're obviously hurting, they've got performance issues, and they said either if you can greatly increase the expressive power, wonderful, or if you can make it perform a whole lot better, we'll convert it, because they were limited in the performance of the shell. And the things that mattered there, by the way, were the size of the shell image, because when you do a fork, in the old days it mattered how big the image was, because you're copying, a whole bunch of stuff. And of course, the other thing the shell did with its own scripts, it didn't do an exec. It did a fork to do shell scripts, but didn't do an exec, so that also saved a lot of time. So a bunch of things like that, which are the obvious optimizations at the time. So that was what we did. I'm not going to go into the online documents, but there were a bunch of feature things that we had to have an argument about. And this is just an example of the kind of list of differences that these guys were going to have to deal with when they did the conversion. So there was a lot of work that they had to do, and they had millions of dollars invested in scripts and stuff at that time. I don't know what it's like these days, but we did eventually go to the racetrack, and we put the PWB shell and this shell next to each other, and we were significantly faster in the benchmark. And so that's how we got. Otherwise, we wouldn't be here today. It would be some other shell. So I do want to talk a little bit about, fast forward to today. The original Thompson shell had 3 man pages. The shell I wrote had 6. That seems like a reasonable number. 6. And then, I didn't tell the seashell story. So one day, Bill Joy calls out. This is in '77, I think, or whenever it was. I don't remember exactly. And he said, "Hi Steve, how's it going?" Blah, blah, blah. He said, "I want to put history and job control into the shell. Can you kind of do that? It's not hard." I said, "Yeah, but it doesn't really belong in the shell. It really belongs in some other part of the system, like in the window manager, or pick another place for it. It doesn't really belong in the shell." So I was a little bit of a purist, and plus I was doing other things at the time. So Bill said, "Oh, okay, I'll just have to go do it myself." So that's how the C shell got going. And it may have been he'd already done it, and he was just, I don't know, you guys may know from being there, but I never went back to Bill and asked him. The bash man pages, and I don't mean to bash the man bash, is 110 pages. That's insane. I mean, I can't read more than 6 pages, and I'm done. So, and obviously it's very functional and blah blah. I do want to make a comment about POSIX, which was something that happened in the early 80s, and I guess it still happens. In fact, I heard something at this meeting about some standards organization doing something ridiculous. But at the time, the POSIX guys were I'll say making things up. In other words, I hope there's nobody here from those times, because I'm going to be in trouble. But No, seriously, the idea of the standards committee, I thought, was to standardize current practice, not to make it up. And so there was a bunch of things that went in, and in fact, McElroy and Janice Ritchie and myself wrote a letter to the posits committee saying, and it was sort of a general grumpy letter about, you know, you really shouldn't be doing this thing. There was a whole list of features that they'd made up and we thought were ridiculous. And of course, they ignored us. That's fine. And I think people have got over it. I've got over it for sure, and it was a while ago. But then there's some things like Dash came along recently. It's kind of like, isn't that like the way it was supposed to be? You know, much more lightweight, and I don't know how many people use it. I don't know what ASH is like, and well, I guess I'll find out. Is the guy who wrote ASH doing? So, shell shock. So this was the thing that went by recently, and this is somewhat speculation, but I just thought it was interesting to throw it out anyway. So, and the reason it's, well, so you all know what shell shock is, right? Yeah. It was the bug that, where the environment, the functions in the environment variables that got passed through exec got evaluated and allowed you to do an exploit because there was stuff on the end that got executed that shouldn't have been there in the first place or shouldn't have been executed. And my suspicion is this code is written in 93. That's the best I can find out. I was unable to reach the authors. I did send them a couple of emails and say, hey, do you know who was doing a witch hunt? I just was interested in it, if they understood at the time what they'd done. And it looked like it was a simple error in using a piece of code to evaluate the environment variable on the incoming side of the process. But the piece of code executed a command line. It didn't execute just the function definition. And so that was a bug. At the time, the environment for the exploit wasn't there. Apache wasn't around in 93. So it's not clear to me that even if they had thought about it, they would have said, oh, it doesn't matter, you know, who cares, you know. So, but my question is, I don't think it took 20 years for people to find it. And so I'm sure there was a bunch of people who exploited that to find their way into systems. At least that's my speculation. So, anyway, the point of this slide is I didn't do it. Okay, so what did work in the way we do development and in the way we did the design for the shell? So, really important. We started somewhere and we didn't get it right the first time, but we had real users who would beat you up and give you good feedback and make good suggestions. And that loop was so tight that we could make progress much more quickly than in some development environments in the real world today. And many of the details, and you know, I can go through, I've been through a couple of them, but many of the details were significantly improved as a result of that loop over maybe a year or 18 months or whatever it took to do it. And the other thing we were brutal about at that time was feature creep. And you know, if you put things in, and you know, Rob Pike's article, which I'm sure you all read, you know, cat minus the sort of harmful was the sort of poster child for that. The end of that story, which is like, can you stop doing that stuff, you know? So, and I do want to make a point here. The shell, the way it is, it's got its limitations. It's because it's blank limited and the strings aren't quoted. There's only so far you can go, and so there's lots of things you might like to do with it. But, you know, cramming arithmetic into a dollar mumble something or other with some crazy APL-like syntax. I mean, some of that is useful, but at some point you have to stop, and it's been like one of these 15th century Baroque things, you know, with all these bits sticking out the side, and how can anybody remember all of that? So at some point you have to give up and use Perl or Python or something else. You know, it's not a string processing language. It has some string processing functions, but in my opinion they are limited, and that's the right way to treat that. So I gave up in '83 trying to fix things like the string processing, because there's things I wanted to do, and I'd like to have done in the shell, but I couldn't figure it out. And so that's why I gave up work on that. I probably should have stayed with it, and you know, I mean, some people stay with their languages all through their lives, right? So anyway, what was not so good? Write-only code. So I wrote write-only code. It was only writable, but you couldn't read it. And I mean, I could read it, nobody else could, because I used macros. It was just like AL68, and it said if, then, else, be, And of course the reason for that was because, I don't know how many, in the old days you didn't have things that match curly braces. So if you edited a file and left a curly brace out, you could take days to find the bug, right? Because, it would be an if and something mumble and a whole bunch of code got included as part of an else clause which shouldn't have done, and go on, the story. These days it's much easier because you've got editors that do the matching and you can see where it is and blah, blah. But anyway, in those days I couldn't see it, and I couldn't see a curly brace. What kind of curly brace is it? Is that an end of an if statement, or is it an end of a case statement? What is it? So that's why I did it. I wouldn't do it again, and before I left the labs, I undid it. And so that was one of the things I wouldn't do again, write only code. The memory management, I'm not sure what we could have done differently about that, other than be much clearer in the documentation for the system when people were doing porting, that was an issue, and help put the right thing in place that wasn't documented well and caused a lot of people a lot of trouble. Because you're porting the system, you'd like the shell to work. That's kind of important. And it didn't because it didn't work. Because it would get this S-break fault and it would die, and people would say, why is it dying? So anyway, do that. I think the fix to that is document properly. I would have put functions in as first-class element. I'm kind of grumpy with myself because I was a language guy and I should have known better. But I didn't, and I should have done that. The other thing, and actually the last time I gave this talk was in Canada, and somebody in the audience, I'm sorry I don't have the name here, sent me some stuff where people can actually debug shell scripts now, and it's pretty cool stuff. It goes through and it tells you what's quoted and what isn't. And, do you remember what it was? That was you. Well, how come you didn't tell me? No. So anyway, Ike sent me this stuff, and it was pretty cool. And you run it on you take a look at the script, and it'll tell you what's there, where the quotes are, and what blah blah blah. It's good stuff. So, but I still think, and there's more that could be done too. And but I would have added debugging support in much more than set -x and some other thing, which is really minimal. The other thing we did, and this again was a performance issue, so if you think about the string evaluation and the quotes, you need to know whether something's been quoted or not so you don't go messing with it, because you're going to read it again, because you're doing other stuff. And so what I did is, in those days, the 8-bit character was only 7 bits used, and so what I did is I used the top bit as the quoting marker. And I probably wouldn't do that again, although I bet it would have slowed it down a whole bunch in those days. These days it doesn't matter. And so what you have to do these days, of course, is use 16 bits and use have the quoting separate, or have some array or some other complicated scheme. But that also was something I probably wouldn't do again, because as soon as Unicode arrived, the whole code had to be rewritten. So I wouldn't have done that. So I got a question for you guys. So, have we made progress? So, let me say why I said that. I tried to do some Android development a couple of years ago. I went and learned Java and all this other stuff, and then somebody said, well, you've got to use Eclipse if you're using Android. And Eclipse is like Mount Everest, I mean, the learning curve is enormous. Well, for me, I mean, my brain is too small for that. And so, I mean, the IDEs are great if you can invest the amount of time that it takes to do that. But even once you get into the IDE, there are still things that you can do with simple tools that, I don't know. So, I asked Ken Thompson this the other day, and he kind of, of course, we're old farts, so we think this is great. So now what? So what I've been doing lately is useful, nothing much, but we do, and there's a number of people in the room who are on the Q editorial board, George, Eric, Kirk, amongst others, and we've been publishing this magazine now for 13 years, and the way it works is we have a editorial board meeting every month. We talk about what's interesting. We get guest experts in who know something, and we turn that into articles and authors. And the way we do that is we say, well, do you know somebody who could write about that? And it would be somebody that Eric, George, and Mike would say, oh yeah, they really know what they're talking about, let's get them to write. So we send them a note and say, how would you like to write? And because we're asking you to write, we're going to publish it. As opposed to if you're an academic and you write it, you throw it over the wall and hope somebody will publish it, and hit rate on that is what I know. Not 100%. And so people who normally would not write will write for us. And we've been quite successful in getting some really good articles and some really good authors. The way the editorial voice is no marketing allowed. So we don't want to hear about the solution, we want to hear about the problem. We want to hear about what was hard about this piece of code you wrote or this thing that you were doing. And that's because we are addressing the software engineering audience. So if you don't know about ACMQ, it's on my phone, and you can get it on your phone, and if you're a member of the ACM, you get it for free, and if not, it costs $20. So that's my shameless pitch for Q. And we publish it every other month, and if you like it, send me an email. If you don't like it, send me an email. I'll send George an email. Actually, send it to George. So Armor 68C, I'm still working on that. Working is probably the wrong word. With a friend in Cambridge who, his name I'm not going to tell you because he'd kill me, because he doesn't want to get emails. We've done the port to the 386. Actually, it was a lot of fun. We took the Z code I was telling you about, and we translated it into C. Because C is the best assembler on the planet, right? That's what McElroy said. He was right. And so we translate Z code into C, and then we use C as the back end. And the cool thing about that was that finding bugs in the translation was easy. Because, like, for example, if the byte alignment is wrong, every byte alignment is wrong. So you see this pattern through the whole thing, you go, oh, that's easy to find, as opposed to a really little sliver. So it turns out it wasn't that hard to debug. We're putting packages together for various Linuxes, and my mission in life, because Kurt won't speak to me if I don't do this, is to install FreeBSD and have this thing work on FreeBSD. So, it's not useful, it's an archaeology project, it doesn't have any connection to the real world yet, there's no libraries attached to it, and so if you want to actually have it be useful, which, I mean, if I get the energy I might do it, is incorporate some connections to libraries so that you can actually do something useful. And the other thing that somebody mentioned here, which is the obvious thing to do also, by the way, is to retarget the back end to use LLVM, and that'll be a bit of a learning curve, but it'll be fun. And the other thing I want to do, just for my own benefit, is to see if the optimizations that were done to the original shell, which I still have the code for, actually make any difference today, or if it doesn't matter. And I suspect it doesn't matter, but I'd just love to know. So I've got the code somewhere, it's just a question of making it work. So that's the story, and thank you for listening. And if you've got any questions, I'm happy to take a beating. Let me get you a microphone, because I want everybody back to be.
So, talking about the original code for the shell, and getting it running on modern systems, just out of curiosity, what is the license on that code?
That's a really good question. It doesn't have a license. I think it's public domain.
It does have a license because
it does have a license. We had to deal with this when we were trying to do the open source for BSD.
Right.
And we got a letter basically saying anything prior to 32V can be freely redistributed with a Berkeley-style license.
Is that right?
Yeah. So it has a Berkeley-style license.
There you go. So I'm okay.
to extend on the
And, you know, if not, so sue me. No, it's a good question, and I would take it seriously, by the way, if I published it.
right.
Yeah, for sure. I need it back.
To slightly extend on that, Caldera allowed this republishing for everything up to 32V before they turned into the evil SEO. So It's published. It can be found on the internet. So.
So I'm around if you want to meet me up or talk about stuff. And thank you, everybody.